into calculus stepping up today. What I had wanted to do with you was the questions on, they call it a number of different things. They either call it optimization, or sometimes they call it min-max problems. But it's essentially the very last question in calculus, which is often a problem-solving sort of question where they ask us to either maximize or minimize something. All right, so the question that I'm going to start off with, because there's so many different types of questions that we can get in this section. So they can give us a 2D problem, they could give us a 3D problem, they could give us something to do with a graph. There have been many sort of creative things that have come up recently as well, where they've asked about the distance between one point and another on a parabola, and you have to minimize the distance. Last year's paper came up with somebody who was leaving home and he had to turn around and go back, and he wanted to minimize the cost, etc., etc. So they really are quite creative in terms of the questions that they give us. But anyway, I'm going to start with a 3D question, and then we can try and sort of build things up from there. Okay, so in this particular question, we have been given a closed rectangular tank that has a square base with a volume of 300 cubic meters. The length of the side of the base is X meters, and the height of the tank is H meters. Okay, so they've given us a picture of it, so at least we're able to visualize the problem. The first thing that they want us to do is find X in terms, sorry, find H in terms of X. All right, so when they say find H in terms of X, which letter do they want us to make the subject of the formula? If they say to us find H in terms of X, which letter needs to be the subject of the formula? The H, exactly, quite right. So the H needs to be the subject of the formula. So now let's make an equation using volume. We know that volume is length times breadth times height. Okay, so we can substitute our 300 in here. We know that that's X, we know that that's X, and we know that that's H. So essentially what we've got is 300 equals X squared H. And now to make H the subject of the formula, we've got to divide both sides by X squared. Not surface area for this one just yet. I'm using volume right now, Paul. So volume over here. Okay, we may use, yes, we are. We're going to maximize surface area. Okay, so we will need surface area formula for this as well. Okay, but at the moment we're working with volume. So there's two equations that we can make with this. So either we're going to be able to make an equation with respect to the volume of the tank, or we're going to be able to make an equation with respect to the surface area of the tank. Okay, so making H the subject of the formula, dividing both sides by X squared, we get H is 300 over X squared, like so. Is everybody happy with that? Thumbs up, feeling good. Okay, so I think here there would be a mark for subbing in and then a mark for our answer, like so. Okay, cool beans. 10.2, show that the total surface area of the prism is A of X equals 2X squared plus 1,200X to the power of -1. All right, so (10.2). Now they want us to work with surface area. So now I want you guys to tell me what the surface area of this box is. How would we work out what the surface area of this box is? Go for it, Butcher. Paul, you're welcome to unmute and ask.
I'm sorry, ma'am, but I was wondering what was 10.2's question because I can't see it on the screen.
Oh, no, sorry. I've moved it off. So they want us to show that the total surface area of the prism is A of x equals 2x squared plus 1,200x to the power of minus 1. That's what they want us to show. So in order to be able to do that, you guys need to know how to work out the surface area of a rectangular prism. So I'm asking you, how do we calculate the surface area of a rectangular prism? There's a formula that we use. Do you know what it is? There we go. That's it, Isona. Lovely. Thank you. Okay, so 2 times length times breadth plus 2 times length times. Okay, you said length times breadth twice, but that really doesn't matter. But yes. Okay, surface area is, okay, 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. Okay, except now they expect us to obviously work in terms of the variables that they've given us. All right. Also, we are going to write surface area as a function statement. So we are writing it as surface area with respect to x. Okay, so if we consider this bit that's down at the bottom that I'm coloring in blue, that would be the same as this one at the top. Okay, so that would be 2x squared, the one at the top and the one at the bottom. Then we've got one on this side, which is exactly the same as the one on that side. Okay, that's x times h. All right, and now we've got the one at the front and the back. Okay, so the one at the front is this guy over here, and the one at the back would be that guy over there. Okay, so it's x long, h high, so it's also 2xh. Maybe that's why you were saying what you were doing, Isona, sorry. Okay, all right. So this gives us a of x equals 2x squared plus 4xh. So our equation looks like this. It doesn't look like that one over there. So what are we going to do now? This equation does not have an h in it. Remember, we can only differentiate with respect to one variable at a time. So we cannot differentiate our statement with respect to x and h simultaneously. So that's why we need to know what h is in terms of x. What am I going to do now? What's the next step? Use what you've got. What have we already done in 10.1 that we can use? Exactly. Okay, we've got h in terms of x, quite right. So now we need to go and substitute. Okay, so in place of our h, we are going to write what h is equal to in terms of x, which is this 300 over x squared. Okay, and then remember, when we multiply fractions together, we multiply numerator with numerator and denominator with denominator. So that's where we're going to end up with 4 times 300 is going to give us 1,200. And then we're going to end up with x all over x squared. All right, so sorry, I'm writing on top of everything here. When we divide like bases, we subtract our exponents, and that's where we end up with 1,200 x to the power of -1. Okay, so it was only out of 2 marks, but I mean, look how much work needed to be done in order to be able to get that. And of course, if you don't know how to write the surface area of a rectangular prism, you have got no formula to be able to substitute into. Okay, so these are the things that are important for us to know. Is everybody okay so far? Is this making sense? Any questions? So here, my guess is there would either be, I think, a mark on that line and a mark for subbing that in, I think. Cool, Tabile. Nice. All right. Now, hence. So in other words, when we see the word hence in maths, it means that we have to use what we've just calculated. All right. So we need our answer from 10.2 in order to do 10.3. Hence, determine the value of x that will result in the maximum total surface area. Okay, so hence determine the value of x that will result in the maximum total surface area. So now what they're asking us to do, Matrix, is that they're asking us to derive area with respect to x. Okay, so in other words, we need to find a prime x. Once we've got our derivative, okay, what are we going to do with it? How would we maximize? Can anybody tell me? Yes, you're going to equate it to 0. Absolutely. So that's after you have derived it. Okay, because this is a quadratic function. So that means that it has a maximum or it has a minimum, doesn't it? Okay, so in this case, because it's 2x squared, actually, that doesn't make sense, does it? Oh, sorry, hence determine the value of x that will result in the maximum total surface area. So yes, in order to be able to maximize it, we know that the gradient at the turning point is going to be 0. So that's why we've got to derive and then make it equal to 0. So that's going to be our next step. Okay, so in 10.3, we are going to find the derivative. So if we've been given a of x equals 2x squared plus 1,200 x to the negative 1. That means that the derivative of a with respect to x is going to be 4x minus 1,200 x to the power of negative 2, because I've got to take 1 away from my exponent. Okay, now I'm going to make it equal to 0, Canisilia, which is what you said, and very important that we show that step, that it's equal to 0. Now we've got to solve this horrible equation. All right, so what are your ideas here? What should I do? What would you do once you'd got to this point? What do we do when we get here, Matrix? How would we go about solving for x? Guys, don't be afraid to share your ideas. Okay, it's no one's judging you. If you don't tell me what you're thinking, I can't tell you if you're thinking something that's incorrect. I can't help you to correct what you're thinking. Okay, so you've got to share what's going on. Okay, so Isona, take the 4x over and divide by negative 4. Okay, Okay, but Isona, can you, I'm so glad, you see, this is the whole point. I'm so glad you said that, Isona. I really am. Are you allowed to divide by x? Can you divide by minus 4x? Okay, so we're not allowed to divide by a variable because for a couple of reasons. Number one, we lose solutions if we divide by variables. Number two, what happens if x is equal to 0? Okay, so then there would be an undefined answer. Okay, so we're not going to ever divide by a variable. You know what I would do in this situation? I would actually take the 1,200 over to the other side. And I'd write it as positive 1,200 over x squared equals 4x. And that 4x is 4x over 1. And now you've got a proportion. And now I would cross multiply. Okay, so I'm going to multiply the denominator, the numerator, denominator with the numerator. And that is going to leave us with 1,200 equals 4x cubed. Now we can divide both sides by 4. So that means that x cubed is going to be equal to 300. And now we can take the cube root. Okay, so here x is going to be equal to the cube root of 300, which I guess we can work out what that is on our calculators. Let's just do that quickly. Okay, so I get 6,69. That's it. Me too, can you see? That's exactly what I got as well. Okay, are there any questions? Is that making sense to everyone? Okay, would you have thought to take the 1,200 over to the other side and then put the x squared in the denominator? Yeah, no, I don't think there is another way of doing it. Okay, so it's very important to know how to do that in these situations. So when they've given you a negative exponent and they're wanting you to solve, you're going to write that base. If it's negative in the numerator like it was here, we're going to write it in the denominator and we're going to give it a positive exponent. And then we can usually cross multiply and find our way out of things from there. Okay, so that strategy is important for you guys. You are never allowed to divide by a variable, Isona. Okay, never, ever, ever. Okay, you never, ever divide by variables. Okay, you can divide by numbers, but you can't divide by variables, because when you divide by variables, I was saying to you, there's two things that happen. Number one, you end up losing a solution. And then also, what if x was equal to 0? Then you would have divided by 0. Okay, so division by variables is not allowed. We've got to think of an alternative strategy. Okay, and this one where you would take that term over to the other side and then write the variable in the denominator with a positive exponent would be the best way to do it, because then you're not losing a solution, and you're not dividing by 0. Oh, shame, Cassandra. Okay, you already did it that way. All right, well, that's good, because then at least it means that you're aware of that and you know how to use it, which is really fantastic. Okay, but as far as the rest of you are concerned, then I'm glad I was able to show you this evening. Okay, so that is a question if they gave you a volume, surface area, 3D prism. Okay, let's go on and have a look at something else. Now, these questions here, I'm hoping will challenge you a little bit more. This is a, well, 10.1 isn't, but 10.2 is a question about velocity, speed, motion, one of those sorts of questions in optimization. But I want us to do question 10.1 before we get to 10.2. Okay, so in 10.1, it tells us if f of x is equal to 3x minus 2 squared and f prime p equals 6, determine the values of p and q if the tangent meets f at the point p and q. All right, so f of x is what sort of function? What sort of function is f of x? Excuse me. It's a parabola, quite right. It's a parabola. And what does f of f prime p mean? This bit over here, f prime p. What does that mean for us? Okay. How are p and x related to one another? Are they the same thing? Are they two different things? So in this situation over here, what they've done is that they've called the x coordinate p. Okay, so x is p. The y coordinate is q at the point of tangency. Okay, so at the point of tangency, x is called p and y is called q. All right, so the derivative at that point, okay, point p, your x, it's equal to 6. So how are we going to use the gradient to calculate the x and y coordinate at the point of tangency? What should I do? What do you think? Go for it, Butchepo.
Ma'am, I think that we should deal with the fx equals to 3x minus 2. We must first expand it, and then we do derivative on it, and then we say it must equal to 6 to be able to find p.
Oh, well done. That's perfect. Absolutely. 100%. Okay, so shall I let you guys try this one on your own? Okay, Nelly and I will sit tight. You guys try this on your own. Quite right. That's exactly what it is. Let's see what you come up with for P and Q. Okay, Sona, I let you do this one by yourselves. All right. That's okay, Tisha. What's going on now is Nelly and I are being quiet and we're letting you guys do question 10.1 on your own. Okay, so it's a parabola. And the gradient at the point of tangency is 6. And you're working out the coordinates at the point of tangency. In other words, P and Q. Okay, and you guys are doing this on your own. Okay, we'll see what other people got, Isona. The other thing that we must also be vigilant of, matrix, is the amount of time that we spend on a particular problem. So you can see that this problem is out of 4 marks, all right? So you should not be spending more than about 6 minutes on it. All right, so if you're wondering how long you should spend on a particular question, what you would do is you would take the marks that it's out of and you would multiply it by 1.2. Okay, so actually we shouldn't have spent sorry, I was wrong. We should have spent 5 minutes on it at the absolute most. If we're not getting the answer, the best thing for us to do is leave it and move on. Okay, well, I think that's really awesome. Okay, so Boitshepo and Kerry and Cassandra, we just need to talk. I'm not sure how you got those answers over there, but you know what? I think it's amazing that you tried. And Isona, 1 and 1 is the correct answer. Okay, well done. That's really good. Really, really good. Okay, so let's just whip through that for the people that weren't able to do it. Okay, so the first thing that we would have done is we would have calculated what f of x is equal to. So f of x is going to be equal to, so this would be 3x minus 2 multiplied by itself. So that would give us 9x squared minus 12x plus 4. Okay, well done. Thanks for sharing your answers. All right, and then as Boitshepo had said, the derivative of x is going to be equal to 18x minus 12 at the point P and Q, at the point of tangent C, the gradient is 6. That's what that bit in the yellow that's highlighted, that's what it means. The gradient is 6 at the point of tangent C. So we're going to make this derivative or gradient equal to 6, so 18x minus 12. And then now what I could do if I wanted to is I could go and sub in my P. Take the 12 over to the other side, that would give me 18, and therefore P would be equal to 1. Okay, so if the x coordinate at the point of tangency is 1, then we can work out the y coordinate by working out what f of 1 is. Okay, so 9 times 1 squared minus 12 times 1 plus 4 also gives us 1 as an answer. Okay, so the coordinates or values of P and Q are 1 and 1. Does that make sense to everybody? Are we all good with that? Oh, shame, Cassandra. That's okay. All right, so remember, when you square a binomial, okay, you've got to multiply, or what you're doing essentially, Cassandra, so in this situation over here, if you just went straight to the answer, so f of x equals 3x minus 2. So important, Cassandra. When you are squaring a binomial, you're always going to get a trinomial as an answer. So square the first term. So 3x times 3x is 9x squared. To get this middle term over here, we multiply the two terms together and then double it. So that's going to give us minus 6x doubled. That's what gives us the minus 12x. And then it would be the plus 4 at the end. Okay. All right, let's have a look at the next question, number 10.2. So they've told us that the distance in meters that an object, oh, sorry, hang on, Tisha. Yes, but I didn't sub. Oh, okay, but now Tisha, all right, the point of tangency is not necessarily always going to be at the turning point. So at the turning point, the gradient is 0. But remember, a parabola, especially one, well, any parabola actually, your parabola is shaped like this in this case. Okay, so you could have a tangent to the parabola here, or you could have a tangent to the parabola there. It's not necessarily always going to be at the turning point. So in this particular case here, we had a tangent to our parabola where the gradient on the parabola was 6. Okay, so when you are making it equal to 0, that is when you're doing the optimization questions. So like the one that we did over here, okay? And the other place where you are making it equal to 0 is when you're calculating the coordinates at the stationary points on your cubic function, because there your gradient, if you were to draw a tangent to your turning points, it would also be parallel to the x-axis, and therefore the gradient would be 0. But if you've got a tangent that touches your function at another place, not at the turning points, then your gradient is not going to be 0. Okay, so here f prime p equals 6 was their way of telling you that the gradient at the point of tangency is 6. Does that make sense, Tisha? All right, no problem. Okay, so let's have a look at the next question. The distance in meters that an object travels in space in t seconds is given as s of t equals t cubed minus 2t squared plus t plus 6. The first thing that they want us to do, oh, hang on a second, Cassandra, you're asking something. Cassandra, no. What your teacher told you to do is your teacher told you to multiply the exponent and the coefficient together. So your teacher is saying 9 times 2, not 9 times 9. Okay, the power rule. You're multiplying the exponent with the coefficient. Ah, okay. Right. You see, that's why I'm so glad that you share what there we go. Lovely. Just want you to share your ideas with me, because if I can see how you're thinking, if you're thinking the wrong thing or something you don't understand, if you tell me, then I can help you. Okay, cool beans, Cassandra. I'm so pleased. Lovely. Good stuff. All right, let's get into 10.2. So the distance in meters that an object travels in space in t seconds is given as s of t equals t cubed minus 2t squared plus t plus 6. The first thing that they want us to do is determine the speed of the object at 4 seconds, right? So they've given us distance. But what they want from us is speed. So if distance is s of t, what is speed? There you go, the first derivative. Okay, so they want you to take the first derivative, and then you've got to sub in 4. Do you guys want to do that yourselves? I'll let you do it on your own, and then you can tell me what you got as your speed. Okay. Can you see less? Sure, with pleasure. All right. So, the idea is that the distance that you travel depends on the amount of time that has gone by. Okay, so S is the symbol for distance, and it's distance with respect to time. Okay, so how far you went with respect to time. When you take the first derivative, so in other words, S prime t, we are talking about speed or velocity. If S of t was distance or displacement. There we go. Lovely, Tisha. It is, there we go. Okay. And then if we talk about the second derivative, then we're talking about acceleration. So if you go back to, let's just go down here, can you see it? If I draw a silly little graph like this. And here I've got time, and there I've got distance, okay? And I do that. All right. Remember from your speed, distance, time triangle, speed is distance divided by time. So speed is distance divided by time. Distance is your change in y, isn't it? Speed or time, time is your change in x. And that is your gradient. Does that make sense to you? Okay, can you see, Lisa? That's why. That's where it comes from. Okay. So your second derivative is acceleration. So that's why when you see the word, if they've given us distance and they give us speed, and we know that speed is our first derivative, acceleration would be our second derivative. Okay, so anybody get an answer for 10.2.1 that they want to share with us? $33. Okay, good. That is the correct answer. Okay, good job, guys. That's it, Cassandra. Lovely. Meters per second is beautiful. Okay, so just for anybody who wasn't able to do that, I'm just going to do it quickly, and then we can move on to the next question, just so that we can say we've been thorough and we've covered everything. Let me just get rid of this stuff. Okay, so we are taking the first derivative. So s prime t, and that would give us 3t squared minus 4t plus 1. And then we're subbing in s prime 4. Okay, so the distance at where time is equal to 4. Okay, so 4 squared minus 4 times 4 plus 1, and that's where you would have got the 33 meters per second from. Okay, good job. So that was out of 3 marks. Must be 1 mark for the derivative, 1 mark for subbing in, and 1 mark for the answer, like so. Okay, on to the next question. You are supposed to, Isona, but you know what? If you don't, you're still going to get it marked correct. Okay, so if you leave off meters per second, they're not going to penalize you. All right, but obviously it is nice if we are given units, we are supposed to work with them. Okay, so 10.2.2, the question now says calculate the values of t for which the speed will be a minimum. Speed will be a minimum. So now what they're telling us to do to speed in order to minimize it. So if speed will be at a minimum, then they are referring to so if we derive the first derivative, what have we got? What have we got if we derive the first derivative? We've got that. We've got acceleration. We've got the second derivative. Okay, so we've got the second derivative when we derive the first derivative. Okay, so we know that the first derivative in this case was 3t squared minus 4t plus 1. So our second derivative is going to be 6t minus 4. Okay, and now we're going to make it equal to 0. Okay, because we're minimizing. So 6t minus 4, which means that 6t equals positive 4, and then we would divide both sides by 6. Let's just get rid of this and that. And t would be equal to 2 over 3 seconds. Okay. Everybody happy? Making sense? Are we all good, guys? Lovely, thank you. Oh, lovely, Tisha. That's so nice to see that. Isona, in this case, yes. So if it's either acceleration or if you are minimizing or maximizing speed, then yes, it will always be the second derivative. Okay. Cool. Okay, let's see if we can quickly do this question before we go. And then we can say that we managed to get through everything. All right, so a family travels through a mountain pass on their way to Cape Town. The car's height in meters above sea level after t minutes is given as s of t equals ... The journey through the pass lasts 8 minutes. Yeah, absolutely. No problem. Let me just... Sorry, I'm not sure how to pronounce your name. Let me just write that absolutely fine. There we go. Okay, so the car's height in meters above sea level after t minutes is given as so. The journey through the pass lasts 8 minutes. In 9.1, how high is the car above sea level when the family begin their journey through the pass? When they start their journey, how high are they above sea level? Anybody know? When they begin their journey, what is time equal to? At the very start of the journey, what is your time? No, Boyd Sheppel. At the beginning of our journey, our time is equal to 0. So we don't have to derive because S of t is distance, and they're asking you a question about distance. So you don't have to derive. Okay, you're actually calculating S of 0. Okay, so they would be 100 meters up. Okay, there we go. Quite right. Yes, it's 0. Good stuff. Yeah. Okay, 9.2. Calculate the rate at which the height of the car was changing. Okay, so now we're talking about a rate of change. Okay, the height of the car was changing at exactly 4 minutes into the journey through the pass. So which derivative do you think they're referring to here? Calculate the rate at which the height of the car was changing. First derivative, exactly. 100%. So we need the first derivative, don't we? So let's work out what the first derivative is. Okay, so S prime t is going to be equal to 15t squared minus 130t plus 200. And again, they tell us the time at which this was happening. So 4 minutes in. So S prime 4. Sub in our 4. And we end up with negative 80 meters per minute. What does this mean? Why is it negative? That's it. Quite right, can you see it? Why is it negative? How do we interpret the negative? It means we have to have been traveling downhill. Okay, so we're traveling downhill as opposed to traveling uphill. Okay, at 80 meters per minute. Okay, that's how that is interpreted. Okay, exactly opposite direction. And 9.3, after how many minutes into the journey will the rate of change of height with respect to time be a minimum? Now, what are they asking you to do? So the rate of height of change with respect to time. So the rate of change is being minimized. This means we have to use which derivative? The second derivative, exactly. Okay, so in 9.3, we're going to take our second derivative. So S prime prime t, which is going to give us 30t minus 130. Okay, so for it to be at a minimum, that would be equal to 0. So 30t minus 130. So, oopsie, just get rid of this. So 30t equals 130, which means the time would be equal to 13 over 3, which we could round off to 4,33 minutes.